One of the advantages of a VFD controller is you can design for the future application or the future pressures you're going to run into today and not have to replace the equipment in the future. Traditionally, you would size the pump exactly for the suction pressure coming in, size the output for the exact pressure going out, and it's a balance between the input pressure and the output pressure. But over time, systems either drop in pressure or they actually increase in pressure. Now they'll drop in pressure because a system is being, a big utility water system is being used by more and more people, more and more subdivisions, so the water pressure drops in the city, so your fire pump can't get to the right pressure anymore. That's one of the problems, and a VFD can help this problem by putting in a bigger pump to begin with. And if you put a big pump in, you can dial it back to exactly what pressure you want, so you don't care that you have the extra pressure from the bigger pump. And then the VFD variable speed controller automatically adjusts that over time, so you don't even need to set it in the future. It just automatically adjusts itself over time based on what the suction pressure is and what the output pressure has been set for. Now the other scenario was that the pressure actually goes up over time. You might ask, well, how does it go up over time? Well, when the city pressure gets so low, eventually they have to add a pumping station, and then the pumping station switches in and brings the pressure much higher than it was before. And with a VFD, it'll just run slower and still work perfectly fine at the system pressure you're designed at. So either over pressures in the future or under pressures, you can design for that for today's job.